Evaluate integral 1 to 2 x to the fourth power positive 1 over x times x square positive 1 whole square times dx. Okay, to evaluate this integral, what I need to do is I have to write this rational function into partial fractions. So there is x to the fourth power positive 1 over x times x square positive 1 the whole square. Okay, so to write the given rational function to partial fraction, I have to look at the denominator. Here the denominator is the product of x and x square positive 1 whole to the second power. Okay, when I look at the first term in denominator, it's just x, and the exponent of this x is also 1. So we just have to write only one fraction for this one. So since we have just x here, we have to write the same x as denominator over here. We have to write a constant a in numerator. Okay, when I look at the second term, it's a square of a binomial. Since the exponent of this binomial is 2, I have to write two fractions for this. Okay, when I look at the binomial over here, so we have x square. The exponent of the variable is just x. If I find the derivative of this x square positive 1, it will be 2x. So the derivative of x square positive 1 contains x. Since the derivative of the binomial contains x, so the numerator in this fraction and in this fraction must have x. So the numerator of the second fraction can be written as bx positive c, and the third fraction as dx positive e. Okay, for the second fraction, we have to write this binomial with the exponent 1, so we get x square positive 1. For the third one, again we have to write the same binomial with the exponent 2. So x square positive 1 whole to the second power. Okay, now I have written the rational function into partial fractions. Now my aim is to get the values of a, b, c, d, e. So these 5 constants. Okay, to get the values of these 5 constants, what I need to do is I have to simplify the expression I have on the right side. Okay, to simplify this expression, I need to get the same denominator for each fraction. So for that, I have to find the least common multiple of the 3 denominators. That is nothing but the one what we have over here, I mean in the denominator on the left side. Okay, so I need to get the x times x square positive 1 out of the second power as denominator for each fraction. So okay, let's continue the next step. X to the fourth power positive 1 over x times x square positive 1 whole to the second power is equal to a over x. Okay, if I want to get this one as a denominator for the first fraction, I have to multiply both numerator and denominator by x square positive 1 whole to the second power. Okay, now in the third fraction, sorry, in the second fraction, bx positive c over x square positive 1. So if I want to get this one as a denominator over here, I need to multiply both numerator and denominator by x square positive 1 times x. Okay, now let me move to the third fraction. That is dx positive e over x square positive 1 whole to the second power. So to get this expression as a denominator for the third one, I need to multiply both numerator and denominator by just x. Okay, now just look at the denominators of all the 3 fractions. So it is same, that is x times x square positive 1 the whole square. Okay, let's continue the next step. X to the fourth power positive 1 over x times x square positive 1 whole to the second power. So here, so the numerator is a times x square positive 1 whole to the second power. Here the numerator is bx positive c, and we can distribute this x to this x square, and 1 I'll be getting x to the third power positive x positive. Here this is the numerator, and this x can be distributed to this one and this one. I'll be getting dx square positive ex, and the common denominator is x times x square positive 1 the whole square. So here already we have x times x square positive 1 whole square. When I multiply this one and this one, it will become x square positive 1 whole square, and it is multiplied by x. And we have x times x square positive 1 the whole square. So the common denominator is x times x square positive 1 the whole square. So here when I multiply both sides by x times x square positive 1 the whole square, this one and this one will cancel out. So I get x to the fourth power positive 1 is equal to a times. I can expand this x square positive 1 the whole square using the algebraic identity, that is a positive b, the whole square is equal to a square positive 2ab positive b square. So using this algebraic identity, I can expand the square of this binomial. So I'll be getting the expansion of this, the expansion of the square of the binomial is going to be x to the fourth power positive 2x square positive 1 positive bx positive c times x to the third power positive x positive dx square positive ex. Okay, now we have completed all the simplification. Okay, now let us continue on the next page. Okay, in this equation, we have 5 constants, a, b, c, d, and e. Okay, now what I need to do is I have to plug in some random value for x such that 4 out of the 5 constants to become 0. So I'll be able to get a value for one of the 5 constants. Okay, now what I'm going to do is I'm going to plug in x is equal to 0 in this equation. When I plug in x is equal to 0 into this equation, so the stuff on the left side will become just 1 because x to the fourth power will become 0 when x is equal to 0. So 0 plus 1 will be just 1. So here in the first term, when I plug in x is equal to 0, this part will be 0, this part will be 0, and we just get 1. 1 times a is a. Okay, in the second term, so when I plug in x is equal to 0, this part will become 0, this part will become 0, 0 positive 0 will be 0. When bx positive c is multiplied by 0, so it will become 0. And when I plug in x is equal to 0 into this one, so both dx square and dx will become 0. So 0 positive 0. So finally, we get 1 is equal to a because a positive 0 positive 0 will be a. So the value we get for a is just 1. Okay, now to get the other values, so what I'm going to do is I'm going to compare the coefficients of x to the fourth power. So because we have x to the fourth power on the left side, so when I compare the coefficients of x to the fourth power, the coefficient of x to the fourth power on the left side is just 1. On the right side, if I look at the first term carefully, when I distribute this a to x to the fourth power, it will be a x to the fourth power. So here the coefficient of x to the fourth power is just a from the first term. So even if we distribute a to the other terms here, I won't be getting any term which contains x to the fourth power, so we can ignore the other terms. Okay, now when I come to the second term, we have a product of two binomials. When I distribute this bx to x to the fourth, x to the third power, it will become b x to the fourth power. So the coefficient of x is b, the second term. Okay, even if I distribute bx to the other terms or c to the x cube or x, I won't be getting any term which contains x to the fourth power. Okay, here is just x square term, it's x term, so we don't have to consider these two terms of our coefficient of x to the fourth power. Okay, when I compare the coefficients of x to the fourth power, I'm getting 1 is equal to a positive b. Already I got the value of a, that is 1, so I can plug in 1 for a, then I'll be getting 1 is equal to 1 positive b. Now I can subtract 1 from both sides. This one will cancel. This one will cancel. I get b is equal to 0. Okay, now I got values for two constants, a and b. Okay, I have to get values for 3 more constants, c, d, and e. Okay, for that, what I'm going to do is I compare the coefficients of x to the third power on both sides. I don't find x to the third. I don't find any term which contains x to the third power on the left side. So the coefficient of x to the third power on the left side is just 0. Okay, if I consider the first term, if I distribute a to this one, it will be a times x to the fourth power. And if I distribute this one, a to 2x square, it will be 2ax square. And a to 1, it will be a. So I don't get any term over here which contains x to the third power. Okay, now let's move to the second term. When I distribute this bx to the x to the third power, it will be bx to the fourth power. When I distribute this bx to x, it will be bx square. When I distribute this c to x cube, it will be cx cube. So from the second term, the coefficient of x cube is just c. Okay, so here the third term does not contain x cube, and the fourth term also does not contain x cube. So the coefficient of x cube on the left side is 0. The coefficient of x cube on the right side is just c. Anyways, from this one, we just got the value of c. C is equal to 0. Okay, now we need to compare. So already we compare the coefficients of x to the fourth power and x to the third power. Now we can compare the coefficients of x square. Okay, here on the left side, I don't find any term which contains x square. So its coefficient is 0 on the left side. If I go to the right side, when I distribute this a to 2x square, I'll be getting 2a x square. So the coefficient of x square is 2a from the first term. Okay, now let's go to the second term. If I distribute this bx to x to the third power, it will be bx to the fourth power. But we need the term which contains x square because we are looking for the coefficients of x square. When I distribute this bx to x, I'll be getting bx square. So the coefficient of x square from the second term is b. And even if I distribute c to x cube or x, I don't get any term which contains x square. Okay, from the third term, where it contains x square, so the coefficient of x square is just d. And the last term does not contain x square. Okay, here we get the equation 0 is equal to 2a positive b positive d. Already we know the values of a and b. We can plug in the values for a and b, so we can get the value of d. So 0 is equal to 2 times the value of a is 1 positive, the value of b is 0 positive d. So 0 is equal to 2 times 1 is 2. We can ignore this 0 and we get positive d. So just subtract 2 from both sides. I get negative 2 for d. Okay, now I got the value of d, which is negative 2. So now I got the values of 4 constants a, b, c, and d. I have to get a value for one more constant. Okay, let me continue that one on the next page. Already we got the values of 4 constants a, b, c, and d. That is a is equal to 1, b is equal to 0, c is equal to 0, and d is equal to negative 2. Okay, now we have to get the value of the constant e. Okay, already we have compared the coefficients of x to the fourth power, x to the third power, and x square. Now I'm going to compare the coefficients of x. Okay, here I don't find any term on the left side which contains x. So the coefficient of x on the left side is 0. So here, if I look at the first term on the right side, so a times x to the fourth power 2x square positive 1. So I don't find any term which contains x. When I move to the second term, if I distribute this c to x, it will be cx. So the coefficient of x in the third term is c. Okay, so the third term does not contain x, it contains x square. So we can ignore that. And the fourth term contains x. So the coefficient of x is e. Okay, already we know the value of c, that is 0. So if I plug in c is equal to 0, then I get 0 is equal to 0 plus e. So finally, 0 is equal to e. I got the value of the fifth constant, that is e. So e is equal to 0. Okay, now I have the values of all the 5 constants. Now we can go back to the original question. Okay, already we have written the given rational function into partial fractions. So into the partial fractions, I have to plug in the values for a, b, c, d, and e. Okay, let's plug in. So x to the fourth power positive 1 over x times x square positive 1 whole square is equal to, for a we know the value 1, that is it will become 1 over x. So for b and c we know 0. So if I plug in b is equal to 0, this part will become 0. When I plug in c is equal to 0, so this one is 0. So 0 plus 0 will be 0. So the numerator becomes 0. 0 divided by anything will be 0. So this fraction vanishes because the numerator becomes 0. Okay, now let's move to the third fraction. The value of d is negative 2 and the value of e is 0. So I get negative 2x positive 0. So 0, if we don't have that positive 0, we can write negative 2x over x square positive 1 whole to the second power. So in the next step, it will be x to the fourth power positive 1 over x times x square positive 1 whole to the second power is equal to 1 over x, and positive times negative become negative 2x over x square positive 1 whole to the second power. Okay, now what we can do is we can take the given integral on both sides, that is integral 1 to 2 dx. Okay, now let's continue the integration process on the next page. To integrate this one, what we can do is we can distribute this integration sign to this one and this one. When I do it, so I'll be getting integral 1 to 2 1 over x dx negative integral 1 to 2 2x over x square positive 1 whole to the second power dx. Okay, already we know that the derivative of ln x is just 1 over x. If we integrate 1 over x, then I'll be getting ln x. So here in the first integration, we have 1 over x. The integration of 1 over x is ln x. So logarithm is defined only for positive values. So here we have ln x. Even if even if the value of x is negative, it has to be considered as positive. So we can take absolute sign for this x. And we have a limit for this integration, that is 1 to 2. Okay, now we can find integration of this function separately without limits. Then once we get the integration of this rational function 2x over x square positive 1 whole square, we can plug it back into this original problem. Okay, let's find the integration of this function without limits separately. To integrate this rational function, I have to look at the denominator. So the denominator is x square positive 1 whole to the second power. A binomial is having exponent 2. Okay, here when I look at this binomial x square positive 1, its derivative is just 2x, that exactly we have in numerator. Since we have the derivative of this particular part in numerator, we can integrate this function using the method of substitution. That is, I am going to assign a new variable u for this particular part x square positive 1 because its derivative is 2x that we have in numerator. So I can assign a new variable u for this x square positive 1. So now I'm going to change, I'm going to convert the complete integration to the new variable u. So here we have dx. When I convert this complete integration to the new variable u, so it has to be du. So from u, if I want to get du, I have to find derivative on both sides. Okay, now in this one, I'm going to find derivative on both sides with respect to x. When I find derivative of u with respect to x, I'll be getting du over dx. So the derivative of this x square positive 1 with respect to x is just 2x. Now I can multiply both sides by dx, then I'll be getting du is equal to 2x times dx. Okay, now here the product of 2x dx, we can write du. And for x square positive 1, I can plug in u. So u, and since x square positive 1 is having exponent 2, we have to take exponent 2 for u. Okay, to integrate this, we can move this u square to the numerator, then it will be u to the negative second power times du. Okay, now we can integrate this one using the power rule of integration, that is u to the power negative 2 positive 1 over negative 2 positive 1 positive c. So u to the power of negative 1 over negative 1 positive c. So if I move this one to denominator, the exponent negative 1 will become positive. So I'll be getting 1 over u. So this negative can be taken over here. So positive c. Okay, so u is a variable taken by us. It has to be replaced by the original stuff, that is x square positive 1. So 1 over x square positive 1 positive c. So the integration of 2x over x square positive 1 whole square is negative 1 over x square positive 1. So we can plug in this result into the problem. Okay, let's go back to the original problem. We got the integration of this function 2x over x square positive 1 whole square just now. So the result of this integration is negative 1 over x square positive 1. So we have limits for this integration. The same can be taken for the result 1 to 2. Okay, here for the first result, ln of absolute value of x, we can apply the limits 2 and 1. So first I have to apply the upper limit, then I'll be getting ln of absolute value of 2 negative. I have to take negative sign. Now for the same result, I have to apply the lower limit, then I'll be getting ln of absolute value of 1. Okay, here negative times negative will become positive. 1 over x square positive 1, the limits 1 to 2. Okay, here ln of absolute value of 2 is just ln 2, and ln of absolute value of 1 is just ln 1 positive. So in this result, I'm going to apply the upper limit 2. So I get 1 over 2 square positive 1. So now I have to take negative sign. In the same result, I have to apply the lower limit, that is 1 over 1 square positive 1. Okay, let's continue on the next page. Okay, here ln2 negative, the value of ln1 is just 0. Okay, since we have positive sign over here, we can simply remove the parentheses over here. In case if you have a negative sign, you may have to distribute the negative sign to this one and this one, but we don't have negative sign, we have positive sign. So even if we distribute the positive sign to this one and then this one, I'll be getting the same. So we can simply remove the parenthesis. I'm getting 1 over. So 2 square is 4. 4 positive 1 is just 5. Negative 1 over. 1 square is just 1. 1 positive 1 is just 2. So I get ln2 positive 1 over 5 negative 1 over 2. Okay, to simplify these two fractions, what I can do is I can do cross multiplication. That is, the first numerator 1 is multiplied by the second denominator, and the second numerator 1 is multiplied by the first denominator. So, and then I have to multiply the two denominators. So, ln2 positive, 1 times 2 is just 2, negative 1 times 5 is 5, and 5 times 2 is 10. So, ln2 positive. So the simplification of this one is negative 3 over 10. In the next step, ln2 positive times negative will become negative 3 over 10. Okay, now we got the evaluation of the given integral, that is natural logarithm of 2 negative 3 over 10.